I'm Jeongho Kim, Associate Professor in Civil Engineering. I'm also Director of Connecticut Manufacturing Simulation Center. So Connecticut Manufacturing Simulation Center is very unique because we do have 504 core high-performance computing power. And also we do have 15 workstations. Each workstation has 10 core processes. We can run large simulations. Using these resources and facilities, we're providing service to local small and medium-sized companies so that they can tackle their engineering problems using finite element technology so that they can optimize their products. The role of each student is to understand the physical problems and then define a model, computational solid model using a commercial finite element software such as Abacus, ANSYS, and LS-DYNA, and run simulations and get reasonable outputs such as stresses and deformations.
Over the past 2 years, I've worked on a couple of projects. The first was in collaboration with Pratt & Whitney and NASA. The main goal of this project was to improve upon the impact resistance of a plane fuselage. It's called a die quenching process.
That involves taking a part and heating it up to a very high temperature and transferring it over to a machine which cools it down very rapidly and simultaneously forms it into the shape that they want it to be.
My work mostly involves composite parameter optimization and damage modeling, and for my research I'm doing development of incompatible graded elements for non-homogeneous materials. The most that I love about doing this research is that I could use finite element analysis. Instead of doing things experimentally, I could calculate and see numerically the values, which is much easier than experimental works, and I could simulate and get the results similar to experiments, and I can change a lot of parameters without physically doing something to the specimen, which is what I love about the computational finite element work.
He came to me and said, "Oh, we're doing this research," and it lined up very closely with what I do at work. And I'm very into finite element analysis, and it's something I want to revolve my entire career around, so I was very excited. I'm not just focused on, one software package. I've used 3. It's given me the opportunity to learn a bunch of new softwares and to grow from it.
We are working on 3 or 4 projects at the same time together, and Pratt & Whitney project and NIH project. We are having meetings together and dialogue together with working professionals and discuss their actual engineering problems, and they visit us also to discuss our progress, our update on our finite element analysis. When you deal with professionals, they have different views even on the same problem, but you have to listen to them, what they're saying about. Also, they have to listen to my students too. So that's why communication skills, I think they learn during this process.
The thing I love most about this research is the fact that I get to work in collaboration with the industry. You hardly get such an opportunity where, whatever research you do or whatever results you get from your research are actually being used to solve a real-life problem. And I guess that's what pushes me to put in my best.
When they have a problem, they have strength, they have confidence, they can do that. That kind of attitude, I think they like to learn. I hope they like to learn from me.